In the second set of notes on section 11.4, you're going to work through the following example problems on your own. Pause the video, and once you're ready to compare your answers with mine, you can hit play. For number 1, you should be recognizing the fact that those consecutive disjoint sides are congruent, and that one diagonal is the perpendicular bisector of the other, making each of those pieces 16. Using 3, 4, 5, and 8, 15, 17 families, we can get that one diagonal has a length of 32, while the other one has a length of 42. We find the area by doing half of the product of the diagonals. For number 2, we should be recognizing the fact that we have a 30, 60, 90 triangle to work with. We're given a side across from the 90-degree angle. That means that x has a value of 6. So one diagonal has a length of 15, which they gave us. The other one has a length of 12 for a final answer of 90 units squared. For number 3, we're given the area of a square with diagonal of 9. Let's be thinking about properties of a square. We know that the diagonals of a square are congruent, so both diagonals are 9, meaning we could find the area of the square by doing half the product of the diagonals because a square is a kite. You get 40.5 units squared for the final answer. For number 4, we're given a rhombus. We know that one side is a length of 25 and that one diagonal is a length of 48. Because the diagonals of a rhombus are perpendicular bisectors of each other, we know that it breaks it up into a 7, 24, 25 family for that one triangle. Therefore, we know that one diagonal is a length of 14, the other diagonal is a length of 48, and we could do half the products of the diagonals to find the area since a rhombus is a kite. And then finally, for number 5, we know the perimeter is 20, so each side of the rhombus must be 5 because all sides of a rhombus are congruent. One diagonal is 8, so we know that the diagonals are perpendicular bisectors of each other. We create some 3, 4, 5 families there, and therefore we know that the other diagonal has a length of 6. So if we do 1/2 diagonal 1 times diagonal 2, we get a final answer of 24 millimeters squared.